Hello, everyone. Welcome to 4 o'clock on day 2. As we round out a day full of information and education, we hope to leave you with something to think about into the evening and beyond. My name is Simone, and I'm honored to be here to kick off this presentation. To start, allow me to introduce you to PriSUM Technologies, the company behind the tools and data we'll be presenting today. PriSUM Technologies specializes in precision mapping for underground assets using 3D gyroscopic technology. This solution provides positional accuracy of the X, Y, and Z planes and is not impacted by depth, weather conditions, or electromagnetic interference. All data collected is self-contained in the unit and then transferred to our proprietary software for analysis and generation of accurate as-built maps. The precise mapping data is delivered to our customers, which in turn increases safety, efficiency, and profitability on the job site. PriSUM Technologies is a division of Conducts International. And today, Santosh, PriSUM's VP of Strategy and Business Development, will be sharing the value of this technology as demonstrated in work done for the New Jersey Department of Transportation. And in this case, which is our focus for today's presentation, IMU mapping tools were used to identify unlocatable utilities in order to mitigate risks and enhance safety conditions during work in their underground utilities. So without further ado, Santosh, please dive into the good stuff.
Perfect. Thank you very much, Simon. Thanks for the quick introduction. But before I jump into the details, I would like to thank the association who had kind of created a platform for us to come down and present this new technology. So my primary focus for this presentation is to talk about how New Jersey DOT kind of adopted the approach to protect their underground utilities without any damage during the new construction. But even before jumping into the details, I would like to give a quick introduction about the IMU mapping tools and then get into the New Jersey DOT project. So a quick introduction, whether it is called as a inertia navigation technology or gyro mapping solutions or IMU, inertia measuring unit, whatever the term is, but the principle of functionality is same. Basically, the tool is built with the gyroscopes, accelerometers, and magnetometers, which will be riding in line to the pipe. So basically, it's riding from point A to point B, and the tool measures the angular rate of change of its core axis. Basically, it's collecting a high sample rate, which is 100 samples per second. And when it is driving from point A to point B, it's collecting heading, pitching, and raw yaw information. So basically, that's the raw data that's collected by the tool. But once we process the data, then we should be able to generate the crisp information in the format of X, Y, and Z, northing, easting, and elevation. So why IMU technology? Again, because of its autonomous nature of inline mapping, it could be able to generate accurate as-built maps, even for the deeper trenchless crossings, which are built with the HTD methods. So what additional value this IMU brings to the industry? Again, we already have many technologies which could able to locate these underground utilities to a higher accuracy, but there are a few instances where this existing technology becomes very much limited because of the access. So for example, if you're operating in an urban environment where there will be a very difficulty for the satellite receptions, then all above ground tracing equipment will be limited to locate the underground utilities. IMU mapping tool, again, as I mentioned, it's autonomous in its nature. So it could be used to map any any utility that's going underground. So that's the one of the advantage it's adding to the industry. These are the two components that are very important for this technology. The picture that you're seeing on the left, it's a hardware which is going to collect the data. And the picture on the right side is more like a software, which is going to process the data and generate the results. So again, as I mentioned, the first step will be the data collection. We need to pull the tool from point A to point B. Again, there is a broad range of the tools that are available. The smallest pipeline that can be mapped is 1.25 inches, and the biggest is 30 inches. So basically, the principle of functionality is same, but there will be a centralizer which is going to be riding on the ID of the pipe. So the smallest is 1.25 inches and the big one is 30 inches. The tool has the capability to map up to 5,000 feet. So basically you're mapping 5,000 feet with the axis on either side. You don't really need any above ground access, but you should be able to generate XYZ all along the 5,000 feet with the GPS coordinate every 1 feet. I want to touch base more on some of these benefits about this gyro mapping tools. The first one is this technology is not limited to any specific utility, whether it is sewer or water main or electric power conduits, or even telecom or gas and oil. Irrespective what the utility is, it should be able to map those underground pipes. Again, basically the idea is we need to provide the provision for the tool to write on the ID of the pipe, and the rest of the job is done by the tool and the software to generate the reports. Again, some of the technology has limitation because if it is unlocatable pipe or if there is no tracer wire, then that becomes more like a limitation. But for gyroscope mapping, whether the utility is a metallic pipe or unlocatable plastic HDPE or concrete pipe, does not matter. It should still be able to generate the accurate plan and profile for the utilities. And the biggest benefit is, as I mentioned, IMU is completely autonomous in this nature. There is no tethered cable, or it's not even communicating any above ground a signal to the above ground equipment. All the data is stored within itself, and once you run the tool, you need to take it out and connect it to your laptop to start processing the data. Whereas the above ground, whereas the EMI or other technologies, you need to have that above ground access to scan the tool. So by doing this, with this IMU tool, we won't be creating any traffic disruption or any other noise to the above ground. So basically, we just need access on the either side through the manholes, and we should be able to generate the data. One of the other biggest benefit is because of its autonomous nature and storing data within itself, it can map the utilities which are going under the rivers, sometimes 100 feet or even deeper under the rivers. We should still be able to locate the utilities. Irrespective of what the soil conditions are, the data quality or accuracy will not be affected. The other important thing is high frequency data. So what we're trying to show here is if someone is scanning above ground, they're going to generate a GPS coordinate every 10 feet or 25 feet or even 50 feet, and later connect those through a point cloud. But for IMU mapping, it's generating a GPS coordinate every 1 feet that accurately predicts the critical bends and undulations in the pipe. Because of collecting 100 samples per second, it should be able to generate this accurate profile. Again, if there is a gas line which is located right by a power utility, and someone is scanning above ground to get the location of that utility, there's going to be a lot of electromagnetic noise from those neighboring utilities. Again, gyro mapping technology does not have any components which will be affected by the neighboring utilities. So the data accuracy is going to be very precise. The other thing is all the data that comes out from this software, it's open platform software. All the data could be seamlessly integrated into any GIS system, whether it is ISRI or Bentley, should be able to integrate the data seamlessly. And the last one is once we perform the mapping, we are able to generate an auditing report, which is going to be very helpful for the contractors to get better understanding of what they are operating. That's a quick overview of the benefits. I want to just touch base some of the recent CGA DIRT report that has identified that 1/3 of the damages that are happening are because of the locating practices. So approximately 160,000 incidents are happening because the contractor does not know where the utilities are, or someone performing an incorrect locating. So what are the potential reasons for these damages? There is so many abandoned lines underground, almost like 41 incidents that has happened in the year of 2020 are because of hitting these abandoned lines. And again, abandoned lines are treated as a lifeline, and we should have a better understanding where these abandoned lines are. And just comparing this to the abandoned lines and locating errors, it's nearly 100,000 incidents that were happening. And the other important thing is most of the expensive GIS systems, which are powerful tools, are currently populated with the as planned data, which is developed during the design phase. But once a contractor in the field, he has to take the deviations around. Again, there may be a good reasons. There may be a rock which he has to take a deviation. So he takes a deviation, but no one is going to go back and put this accurate as-built maps into the system. If someone is accessing the ground to put the new utility, maybe 5 years from now, and if they are looking at the as-planned map, there is a high possibility that they may cross-bore or cross-bore into the existing utilities. So it's important that all these GIS systems populated with the as-planned map. So now let me get into the actual topic, which is the New Jersey DOT project, which we have worked to locate some of the utilities. Again, the project, this is a huge project. It's estimated to be at $320 million that they are trying to replace a bridge. And again, this is a very critical bridge, which is connecting the Stafford Township, and it's connecting Long Beach Island. And this is the only communication for this island, which is a very critical bridge. And they are trying to make some replacements to the bridge, and they want to know where the utilities are so that they don't damage them. Again, this is a $320 million investment, but it has been properly designed by the New Jersey, and it's been broken into 6 separate projects so that they kind of have a very good understanding. They have developed a team called as a smart scoping team, and this team was performing the value engineering to make the right decisions and to avoid any potential damage to the critical infrastructure. They have adopted this disciplined subsurface utility investigation prior to the construction to know where the utilities are and also come up with the mitigation plans for the risk. So there are so many utilities that are involved. It's hard to read here, but telecom, Comcast, water and sewer, and electric conduits. So they want to get a pretty good understanding where these utilities are when they are trying to replace this bridge. Again, what the reason, the biggest reason here, again, I'm trying to drill down to the very specific situation that we encountered on this project. So they are trying to build a drain line as the island was kind of getting flooded during the rainy season and also because of the high tides. So they want to build a new drain line into the water. So the existing water main, they don't really have a good understanding where the water main is. They are just going off of the as-planned map, which is not a reliable data. Again, this is a very critical infrastructure. This is the water main, which is connecting the whole island. And if they cross-bore or damage this water utility, then this is going to put the whole island without water until the utility is repaired. Again, in order to build this drain line, the first thing that they have to do is they have to build a coffer dam near the water main. But not knowing the true depth of this water utility, they cannot build a coffer dam because there's a possibility while they are kind of piling the sheets, they may cross-bore into the water main. So the idea is trying to locate the true location of this water main. But again, traditional locating equipment does not have ability to do anything which is going underwater. And PriSUM was kind of helping the group of people to locate this water main. The 5 parties that were involved we were kind of working with the New Jersey DOT and also WSP, which is a subsurface utility engineering, who are kind of doing this design construction. And we're also working with MNS and also the Mathis Construction Company, who are kind of doing the utility relocation. And basic idea is to understand where the water main is so that there is no damage to the water main. So again, they have to excavate the water main on either side of the island for us to launch this mapping tool. So we were launching the mapping tool on one side, and we have to collect the mapping tool on the other side. So basically, we will be running 4 runs from point A to point B. And again, the idea is to see the data that we collected is repeatable or not. And in this scenario, we got a high repeatable data that giving an indication that the data collected by the tool is very accurate. I'm going to show what level of accuracy we have attained on this project. The other important point, once you collect the data, the critical input for the software is a known GPS coordinates on the either side of the waypoint. So we have collected the survey grade GPS coordinates centimeter addition on point A and point B, which become more like an input to the data. And once we process the data, then we should be able to generate an accurate XY area view, and also show how the depth is changing from point point A to point B. And this is the final auditing report that the client was really interested to look at. So let me give a little bit more better understanding here. Again, when we started this project, the team was thinking that the HDD contractor was sitting in the middle of the street and trying to bore the water main to connect it to the other side. So they made a decision that they're going to have the drain line completely out further away from this water main. Again, when we did the mapping, the water main is not going straight. It is making an angle and trying to get to the other side. So not having this true as-built information of the water line, which is the red line here, they would have cross-bored into the water main. Again, cross-boring into this water main would have been very expensive to the project, not only on the cost, but also the project delay. So once we provided this accurate information of this water main, then the team went back to the drawing board and started redesigning this new drain line and trying to ensure that there is enough room for the coffer dam and also the water utility. So this specific project was just a one-day activity where we were able to run the tool and also show the results to the New Jersey DOT on the same day. So we don't really have to spend a lot of time. This was the overall operation time for this project was 2 hours, and we were able to collect the data, and we were able to share the results right in the field. So WSP, who was the project managing on this specific project, they took the data, and the primary interest is to understand what is the true depth of this water main at this specific location. And we were able to give them a GPS coordinate every 1 feet, so they know what the depth at this specific location, and they have designed the coffer dam accordingly so that they don't really get closer to this water main. So according to the New Jersey DOT, the locating standard tolerance is plus or minus 2.74 feet in horizontal over the length of investigation. And the accuracy they were looking for was 1.09 feet in depth. But the 3D mapping data that we collected and shared the results was much more accurate. It was 0.26 feet accurate in XY and 0.3 feet in Z. So this is a high accurate information, which really helped the team to make the viable decisions in the field and ensure that there is no damage to the water utilities. Again, we shared this information with the New Jersey DOT. They were pretty much happy because they were not sure there is something, they were not sure about this technology is existing. So which really helped them to keep the project on time and trying to avoid all the risk upfront with those mitigation plan of locating the water main. So I'm kind of getting close to my presentation. I want to give more time for questions, but the industry is moving towards augmented reality. Again, those augmented reality are very powerful tools, and it's very important to maximize the value of those tools if you are able to get the as-built data. Again, if you are putting the as-planned data into these powerful tools, probably will be beating the purpose of the technology. So it's very important that all the network owners generate their as-built map, accurate as-built maps, and enrich their GIS systems. So that concludes my presentation. Again, we are PriSUM Technologies. PriSUM stands for Precision Subsurface Utility Mapping. Again, we can map any utility that is going underground. I have my contact information, and please let us know if you have more questions. We can schedule an offline meetings with you to get more better understanding on this technology.
Fantastic. Thank you so much. I was wondering, I was curious, I was listening to your description of the New Jersey, the work that was done there. Do you have any projects, future projects you can talk about, or interesting ongoing projects other than New Jersey that might help illustrate the capabilities of PriSUM?
Exactly. And again, we are working with other DOTs. We are working with Delaware DOT, and there are many projects of this nature where this technology is adding a lot of value. The existing technology is kind of more limited to provide this level of detail. So there are many projects that are coming of this nature. Again, anything that is going underground or HDD crossings, this adds a lot of value to provide accurate, and the accuracy is very important, which is what IMU mapping tools are known for.
Thank you. So we got some questions from the attendees. I'm going to read them out for you. First question, for pressurized fluid gas pipes, does the pipe need to be depressurized to use the IMU mapping?
Well, that's a very good question. I didn't really touch on this presentation, but REDICT, PriSUM, and the GTI work with regulatory body PHMSA, which is Department of Transportation, and came up with a solution which can map a pressurized gas pipeline. So without interrupting the flow of gas, we should be able to map a gas pipeline. And again, this is called as a vertical hot tap entry. We are vertically entering into a 2-inch gas pipeline and should be able to map on the either side of the feeding. So that's something that is we have already proven with the gas utilities to map without interrupting service to the clients.
Thank you. There's another question from the attendees. Does accuracy of the measured results decrease the farther from the insertion point?
That's a good question, and that is true. So more further away we go from the starting point, there is going to be an error which is called as a drift, which will be added to the equation. So more further you go, the error will be accumulating on top. But based on the guaranteed calibrated accuracy, the tools that's been calibrated, it's calibrated over 5,000 feet to meet a 6 inches in XY and 4 inches in Z. So that's a calibrated accuracy. But once the tools gets into the field, there is going to be operational errors or pipeline conditions which may affect the data. But the guaranteed accuracy is 5,000 feet with 6 inches in XY and 4 inches in Z.
Another question from the attendees. What kind of formats do you deliver the data with? And in what platforms do the clients normally use it?
So the data that comes out from the software is a CSV file, which is northing, easting, and elevation. But most of the GIS system, in order to make the process more seamless, we can convert the data into a shapefile. So the shapefile are more easily integrated into any GIS system. So there is a CSV format. We can also generate the KML file and the shapefiles.
Thank you. You have the honor of being our last presenter at an incredible event. Is there anything you would like to leave the conference with about PriSUM and some of your thoughts?
I would like to thank the organization who has kind of created this forum. There were so many informative sessions that has happened. Again, I kind of came through some of the technologies which I was not aware of before. Again, the IMU mapping tool is not new to this industry. It's been there for quite some time. So we are trying to build a pitch to the industry that there is a technology which can avoid risk when you're trying to put the new utilities underground. So it's very important to know where the existing utilities are. And again, there is no silver bullet which can locate everything that is going underground. So every technology has its own value, and the IMU mapping tool is adding value in specific situations. So we are just a tool to the contractor, locating contractors toolkit. We should make very right decisions when we are trying to work underground. So underground is more becoming like a ticking atom time bomb. So we should know where our utilities are before we take any step forward.
Well said. Thank you so much on behalf of the conference and Go Geomatics Canada. It's been a pleasure hosting you today.
Perfect. Thank you very much, John.